Hello class, that time of the week again, it's time for your practicum. So this week we're talking about basic terrain analysis in grass. And I know last time we had kind of a pretty massive introduction to grass, and you're still probably wrapping your mind around the differences between grass and QGIS and other GISs. So I encourage you to go back to last week's practicum and to look through it again. I know parts of it were a little bit rushed, but especially look at the introductory parts about how to get grass started. And last week we were still dealing with our Kazakhstan data, but this week we're making the transition to data from Wadi al-Hassa in south central Jordan that we're going to be using for the next two projects, and we're going to use basically grass to do these two projects. Now, last time I showed you how to set up a brand new basically grass location map set kind of thing. This week you're going to be working with one that I've created for you. And so you'll go up to Blackboard and you'll download this project 2 zip, and you will copy it over to your grass GIS database. You'll see the one you made last week here and this one, and then you can just extract here, and project 2 is there. So what you really need to do is to move this one into this one right here. And now project 2, whoops, I'm hitting the control key, and the zip you can move them up over here for now. So inside project 2 you'll have the description, and then you'll have a few of these things that we'll get at a little bit later, starting next week. Okay? But really all you need to make sure is that inside GIS database is this Hassa underscore WGS84 UTM zone 36 north grass location that has a permanent map set in it that has a whole bunch of stuff. Okay? So basically that's all you have to do to get ready. It's just got to be in your grass database, this Hassa WGS84. All the other stuff should be outside for now. Okay? And in fact, you don't even need to keep these zips. You could delete them if you wanted to. At that point, we're going to start grass, and we can start it multiple ways. I'm going to just start it the graphical way, just so you can see me do that. Grass 7. Remember, this is our splash screen. And because last time we pointed it to our GIS database, it's coming up this time with the same path. Now, if you've moved things around in the time since, you might get a little red message that says, hey, can't find this. You just browse back to wherever you put it. And as long as it's got one location that has a permanent map set in it, it will be fine. By default, this one remembered my location from last time and that I was in permanent. Here we're going to move to Hassa WGS 84 UTM zone 36 north. I have set up the permanent map set to have basically 3 maps in there, to have a raster SRTM background, and then to have 2 point vector files of some survey data, real archaeological survey data that was done in Wadi Hassa. Last time I said you set permanent up with your base maps, and then you make a new map set so that you don't accidentally delete some of those base maps. Now we're going to follow that advice here. So I'm going to click New. It says Create a new map set, and I'm going to just call this one Project 2. And I could put a little underscore if I wanted to. Now what's really great is that because this location is already named very descriptively, I can actually call this Project 2, or I could call this Terrain Analysis, or whatever it is. And now I have this whole like nested hierarchy of information. Hassa WGS 84 UTM zone north, that's all the projection information, the location in the world. And now my map set Project 2, I can say, okay, all the work I'm going to do for Project 2, I'm going to keep in this map set, and grass will keep everything organized in there for me. And at this point, we're ready to start grass. So we just click Start Grass Session. We wait for the cool splash screen to pop up, and then we get to our 2 windows that we saw before. Now, where's all my layers? Where's all my data? Well, it's in there, right? I briefly pointed last time that these little buttons are what you do to add basically layers to the layer manager so that you can see them on the map canvas. So this is the one right here. These ones that look like little checkerboards are for rasters, and these ones that look like V's are for vectors. So let's go to this one that says Add Raster Map Layer. It's got the little plus sign next to it. This is the general one. And then we get our drast module pops up, and we have to go down here, and we see we only have one raster, and it's in permanent. Now you see we are in Map Set Project 2, yet we can still see the maps that are in permanent. That's because permanent is always visible. Later on I can show you how, if we have more than one map set, how we can turn them on or off depending on if we want to see the maps inside them or not. And that's the benefit of using multiple map sets. You can just compartmentalize, or you can expand if you want to. If you have a lot of maps and you just want to hone in on what you're working now, it's great, so that you're not scrolling through. Every time you go to add a map, you're not scrolling through 20, 30 maps to find the one that you want. So I'm going to click OK to add that, and it shows up here. Now, just very briefly, if I wanted to control those, which map sets I saw, I would basically go to this particular tool. I go to Settings, Grass Working Environment, Map Set Access, Gmap Set, and here I could check or uncheck the ones that I want to see. And even I can uncheck permanent if I didn't want to see the maps in there. Right now we don't have that many maps and we want to see all the ones in permanent, so we're going to leave these all checked. This is just something to file away for when you really start working with grass in earnest. So that's my raster background. This big canyon here, that's Wadi al-Hassa right there. So that's the area that we're going to be working in. We're going to add very briefly the vector file. So V, and we'll get the one that's got the little plus for now. And we'll pick, there are two surveys, Wadi Hassa survey and the Wadi Hassa North Bank survey. So let's add Wadi Hassa sites. Click OK. And let's do another one. We'll add the Wadi Hassa North Bank sites and click OK. Now, if we wanted to style those, we could definitely style those. We could go to, let's just do colors for now. Pick red for our Wadi Hassa sites, and we could pick, I don't know, let's pick yellow for our Wadi Hassa North Bank sites. And that might be useful for when you're making your final map, right, for Project 2. But for now, we're just doing that for fun. Because really what we're interested in is the topography underneath these. So I'm just going to uncheck these boxes to hide them for the time being so that we can focus on this topography. By the way, you'll notice that this window and this window are not going to be full screen. If you want to, you could expand this thing and use full screen like this. Grass, unlike QGIS, doesn't have the sort of docked interface, meaning you don't have those sort of tabs over here. You've got this sort of floating window interface. So you could work on full screen, but very frequently what I like to do is to just resize my window. So if I take away from full screen, I like to resize my window just a little bit bigger over here, kind of like that, and keep this one visible over here. Now, you'll find your own workflow. It depends on, I'm going to move me down here. Depends on how big the monitor is that you're working and that kind of stuff, but you'll get your own sort of way you like to organize your two windows here. But it is a little bit different than QGIS. Okay, back to terrain analysis. We're going to do just some real basic stuff like we talked about in class today, slope, aspect, etc. So first of all, this is a raster. It's a DEM. All the cells in it have numbers that relate to the elevation. What we want to do is to analyze the relationships between one cell and the next cell in terms of the changes in elevation at different scales for different reasons. Let's just start with the most simple tool. We go to Raster Terrain Analysis, and lucky for us, we have a bunch of things in here, and we're going to use several of these. And we'll go to r.slope.aspect and calculate slope and aspect. We get our module up here, so let me just make it a little bit bigger so you can see what's going on here. And the first thing I want to do is to go to the man page. The manual page, as I always say in Grass, one of the great things is that the manual is right there in every single module, and it gives you a description of every single box and check mark and all the things that you could possibly do. And then it describes in general what's going on, and it tells you specifically how it's going to calculate the things like slope and aspect and all the other stuff that it can do here. Okay, including where is 0 directly east is 0, and then we go counterclockwise around, just like I mentioned in class. And here we have how, in an example, 16 by whatever, 16 cell, what did we say, 25 cell area, a 1, 2, 3, 4, 5 by 5 neighborhood, the aspect would be calculated, and how it would look, and also slope, how exactly it would be calculated. etc. All right, so just read through this if you're interested, but basically we covered that in class over here. So really in operation though, Grass is doing all the math for you. So you have the concept of what it is that you're doing. You let Grass handle the math. You just make sure you understand basically what's going on under the hood. So required tab, name of elevation map, HASA 30 meter SRTM. Output tab. Now you might have tabs across the top depending on what version of Grass or the way you set it up. Mine happen to be over here on the left. Output slope raster map. We just type HASA slope, right? Aspect. We can do this all in one. HASA aspect. Actually, and what we might want to do instead of just writing HASA, we might want to write HASA SRTM 30M slope so that we know the resolution in there. HASA SRTM 30M aspect. And while we're here, we're going to calculate the two curvatures that we talked about in class 2. HASA SRTM 30M. This is profile curvature in the direction of the steepest slope. Curve, right? I'm just going to copy this one so I'm not typing so much. And tangent, tan, I'm just going to call it tan curve. Now this is perpendicular 90 degrees to the direction of slope, so it's the horizontal curvature. It all makes sense when we have a look at it. We can look at some of this other stuff, but basically the defaults are fine for now, so we're just going to hit run, and it'll chug along. Now I set the default region and resolution and all that kind of stuff, but remember you should always check it with gRegionD and gRegionD-P to print it out, just to make sure that the region boundaries and the raster resolution are set properly. If you ever hit run and it seems to be taking forever, chances are the resolution is either really, really fine or the region is set for basically all of the Middle East or something like that. So it always pays to go back and reset the region to match specifically. The easiest way to do this is to go over here and just make it set computational region from the SRTM 30 meters, and then you know it's set perfectly and you don't have to worry about it. At this point, we are done with our slope aspect, so we can close it. And you're looking at this crazy stuff going, what's going on? Well, those are the curvatures. We'll get back to that in a little bit. That's the aspect map, and this here is the slope map. So what we can do really quickly is to just go over here and give ourselves a key to work with. And the way we do this is to go up here and say add raster legend, and we want to pick our slope map over here. We could do all kinds of fun stuff with it, but for now we'll just hit apply and see what happens. Okay, we've got our little, we can actually drag it and move it around. I'm going to put it over here for now. So basically this shows the slope from 0, the minimum slope, to in this case 72, the maximum slope. We can style this, we can change the colors and the size of the bar and all that kind of stuff in dLegend over here if we wanted to. I'm going to let you click around in this for yourself, and you can again read the manual which exists down here if you want to learn what all of those things do. But basically you can do whatever you want. And so now we start to be able to interpret this particular map, and we see, okay, yellow is flat, green is still pretty flat. Okay, when we get into the blues, that's 18 degrees, it's kind of steep, and then the magentas and the reds are really steep. So we can really see how we can go from this view of just the elevation colored to this one, and we can really start to see, right, the differences here. Now, maybe we want to just highlight some of these areas. What we can do, if we double click on this and we get the display, we could also have gotten this, right click and gone to properties, same deal over here. If we go to the selection over here, we can actually just tell Grass to display, now not delete, but just display some range of this thing. So I want to see everything above, let's say 30 degrees slope. So I would just put 32 and I'll just put 100, even though I know it's not 100. If I hit apply, let's see. Oh, did I do that right? 30. Where is it? Every time I have to resize this so I can see all my options. Yeah, let's see. 30, what did I do? maybe 30 to 72. 30 to 72. Wow. Okay. Let's try just 30 and see what happens. Oh, yeah, here's my mistake. I right-clicked on the wrong map. I was looking at the SRTM, so let me delete this. That's going to be bad, and go to the slope map. And then properties, selection, 32, 100. Now I can hit apply. There we go. Okay, that's what I meant to show you guys. Sorry about that. So you can see that I could change this. I can make this lower. I can make this 20 to 100. And you can see, so basically I'm just displaying the values from 20 to 100. Now it only goes to 72, so basically it's everything above 20 in this case. I could do a little sandwich, so for example, I could do 10 to 20, like that, and if I hit apply, there we go, so we're just showing the blue things over here. I could do 0 to 10, and I could put a comma, and I could put 20 to 30, I could hit apply, and now you can see I'm showing two intervals, 0 to 10 and 20 to 30. And then I could also do 50 to, let's just put 100 for now, right? Oh, and then the little tiny little areas, these really, really steep areas popped up right here. If I want to get rid of that, just delete all of that, hit apply, and I'm showing all of it again. So this is really useful for you to see where the high areas of slope are. Let's say 20 to 100 again, like that. And we just hit OK, right? So a real simple way just to help delineate zones of the landscape. Remember, that's what we were talking about. The point of topographic analysis is to start characterizing, describing, and categorizing different parts of the landscape. Here we've done a real simple visual categorization of just the steep sloped areas. Let us now turn to aspect. Remember, aspect is simply the direction of the steepest slope. So whatever that value for slope is, if you're standing on the cell, that's the direction that you are facing. And really here, the colors now, let's just double click over here. If I double click on this, I get my D-Legend menu back up. And I'm going to switch this to aspect. And now we can see that it's 0 to 360. Remember, it's 0 is east, and then you go all the way around to 360, okay? When you look at this, you're starting to realize that the color scheme that's chosen for aspect is kind of like shadows, right? It's like the sun is somewhere, and we're actually seeing the relief of the topography. Now, this is really interesting. Let's do something. Let's drag aspect all the way to the bottom. And you're going, what did you do? It just disappeared. Well, let's go to the HASA SRTM that's right above it. Let's right-click on it and go to Change Opacity Level. And we'll drag this bar down. Let's go about 50 for now. And hit Apply. Okay, maybe a little bit less than 50, maybe like 65. Yeah, maybe even a little bit more. Let's go to like 70. There we go. All of a sudden, you're getting two forms of information into your eyeballs, right? The shadows are making the topography pop, and then the colors are influencing it. Now, this is really cool because our brains can help see some of this stuff almost like it's in 3D. Now, we can look at this stuff in true 3D, which we will in just a second. But before we do that, this is going to bring us to something called Hillshade Analysis. We're going to get back to the curvatures in a little bit, but let's do a basic hillshade. So let us make this all the way opaque again, like that. We'll go back to raster, and we'll go back to terrain analysis, and then we will find our compute shaded relief, r.relief, and HASA 30 meter SRTM. If we have it selected over here, will show up by default. Otherwise, you pick it from your list. And over here, we put HASA SRTM 30M shade, and then I'm going to put in X2, and I'm going to get to that on the next tab over here. The optional tab where it says factor for exaggerating relief. Now, imagine you took a mountain and you doubled its height. The shadow that it throws is going to be twice as big, right? Bigger shadows makes the relief pop more. So we can exaggerate the relief by 2 times, and the shade map that we create will just accentuate all the topographic differences. I glossed over some position. This is all pretty good. If you wanted to simulate the morning versus the afternoon, you could mess around with these tabs here if you wanted to. At this point, we'll just hit run. The shaded relief is calculated. I'll hit close. And I'll just show you, I'll compare it to the aspect map. It's pretty similar, but there are some few differences. The difference mainly being the colors are a little bit better and the way that this is calculated, because the sun is actually in a logical position. So it looks more like we expect to see if we were looking out of an airplane or something like that. And so the simplest thing to do at this point is to put this just below HASA SRTM 30 meters, turn that on, and change the opacity level again. Let's go back to our about around 70, right? And you can see, oh, that looks even really nicer. But there's a better way to do this. So let's just put that back, which is to go up here. Instead of the regular add raster map, we go to the add various raster map layers. It's the one with the little, I don't know, arrow or something down here. And then add shaded relief map layer. Lets us put the shaded relief map that we just made, shade times 2, at any colored map that we want. It could be slope, it could be regular topography. So we'll start with regular topography, and then we'll just hit apply for now, and we'll see that, oh, it looks kind of dark. So we'll go to the optional tag, and we have this percentage to brighten. I usually think about 30% is pretty good. Yeah, look at that. Now that's really popping up. This is called data fusion. We are fusing two layers of data so that their colors are melded together. The shading of the hillshade and the colors, in this case, of our HASA 30 meter SRTM. Let's try fusing another layer instead of the SRTM. Let's put our slope layer on there. Oh, look at that. Yeah, the slope is starting to make a little bit more sense. We can see that the slopes and the shaded relief, you see exactly how they go together, right? Now, let's add our profile curvature map. And that will start to make some sense now. And this is the reason why I waited a little bit to show you the profile curvature. Let me zoom in on one of these areas here. And let me change this legend to be the profile curvature. So you can see it's around 0 somewhere in the middle, and then it goes negative to positive, right? So the blue colors are negative curvature, which is concavity, and the red colors are positive curvature, which is convexity, right? So now you can really see in the direction of slope, when it's changing really fast, you get a high convex curvature, and when it's changing fast the other way, you get a high concave. Let's add the tangential curvature. And we will change our color schemes over here to be tangential curvature. And we will see there's a lot of them in this case which are, I think they're 0, which is why they're kind of black. So if we zoom out just a little bit, but it's the same deal, but it's actually turning in this direction or this direction. Perpendicular 90 degrees to the direction of slope. Okay, so let me zoom out all the way. Zoom to selected map. And let's hide that guy for now. In fact, let's hide all of them except for the SRTM. Because what we want to do now is to go up here. And we've not played around with this stuff up here. You see where it says 2D view? Let's change it to 3D view. Look at that. We have a whole bunch of new tools over here, and we have this perspective view over here. What's first thing you'll do is to go to the View tab, and you'll see this thing. And if you drag this, you can spin around, and you can view from this direction. So imagine yourself being at this little dot. That's you. And if you're further away, you're sort of zooming out from the landscape. And if you're closer in, it's like you're flying in, you're hovering in a drone or a helicopter or something like that. And then this perspective here is like you're using a telescopic lens or something like that. The further you zoom in, the little bit more distorted it gets. The further you zoom out, the sort of more normal the view. And it tells you right here, this is essentially like the millimeter view. So if you want what they call a normal view, just put it somewhere at 50. It's like using a 50 millimeter lens, more or less, okay? You can change your height above the ground by sliding this. And over here we have, again, Z exaggeration. So again, if you do this, it's going to make it zoom away because you're multiplying all your factors in there by, in this case, 3, right? But if we then zoom ourselves in, let's just zoom in with our telephoto lens, and we zoom ourselves back down a little closer to Earth. Okay, a little close. We can actually see all the topography is exaggerated. Now you may be saying, hey, I thought that SRTM was 30 meters. Why does it look all granulated? Well, we have to go to our data tab over here. By default, it makes it display at a lower resolution so that it's faster, renders faster on your computer screen. And that's what we have over here. We have fine mode and coarse mode. Coarse mode is basically as you're zooming around, so I never move coarse mode around. But fine mode resolution, I usually want to reduce all the way to 1, so I'm actually seeing the true resolution of the map over here. And the cool thing about this is when we're in the data tab over here, we can go to the color attribute. So if you just scroll this down over here, the elevation data, the numbers in the cells will be used to make the relief in the 3D image. But we can get the colors from anywhere, much like we were doing with that hillshade map. So if we go here, we can grab slope, for example. And now our 3D map, if we go back to our view tab and move it around, is colored by the slope, right? This is another kind of data fusion. Now, the other thing we can do, we can just grab on here with the little pan tool, and we can move around this way. So if you're more comfortable panning and moving the thing around, it moves kind of strangely because you're kind of locked in your perspective and the landscape is moving at arm's length from you. But once you figure out how it moves, it starts to make sense. You can tilt and whirl and all that kind of stuff. And you can type numbers in there if you want to go back, right? You could type numbers everywhere, for example, and it'll change it back. Now you'd be saying, hey, this looks kind of dark. Can we move the sun around? You can. Go to the Appearance tab, and basically you get another, it looks very similar to the View tab, but in this case, this is the position of the sun. Whoa, look at that. I can move the sun around. I can move it closer, like high noon, like this. I can make it basically be early morning, or I can make it be late at night, right? Or I can make it be something that never happens, the sun coming straight from the north. We typically don't do that, right? We want to sort of mimic what we might see in real life. So very often what we want to do is to sort of say, hey, really late sunset or something like that, where the shadows are kind of nice. You can drop the height if you want to this way. And then if you go down, let's see, to, let me resize this. Sometimes you have to resize this so you can see everything. To brightness, we can lower the brightness a little bit, but we can turn the ambient light up. This is kind of like the harshness or the softness of the light you can play with over here. And what's really cool, we can also add things like scale bars and north arrows if we wanted to by placing them in there. So you can fool around with some of this stuff over here. If we go to the Analysis tab, we can do a cutting plane and add one right here, and we can move it around like this. This is only kind of useful if we have two map layers in here and we want to fade between them. But you know, these are things I can show you one-on-one if you wanted to. So let's turn the cutting plane off. We're looking at it again. So really what we're doing here is getting a nice perspective view in this thing. And if we wanted to save this out, by the way, we can change our scale back to be slope over here. So let's say we wanted to save this out. Well, we could go up here and hit Save Display to File, click OK, and then I could type a file, my 3D image, right? This is just in my home directory, and click OK. And if I go back to my home directory, somewhere down here, if I get myself out of the way, I will find my 3D image.tiff, and there it is, right? The same image. So that's a pretty cool thing to do. You might want to do that in some of your projects over here. We have one last thing to do for terrain analysis for now. Okay, so I'm going to put this back to our 2D view, and what we're going to do is to classify the landscape, and we're going to do this with a, there's one of two tools that we can use. We can do, I'm not going to talk about add-ons yet. I'm going to wait for a little bit later to do add-ons, but there's an add-on for grass called I think it's called Geomorphon, which does a slightly better classification of the landscape. But there is a built-in tool that does a pretty good job as well. And if we go back to terrain analysis, and we go down to where it says terrain parameters, r.param.scale, just click on that, we can actually calculate a whole bunch of things in here. Now the important thing is scale is in this. So we talked a little bit about scale and why it matters when we calculate slope. If you calculate slope over 3 cells, it's going to be different if you calculate it over 6 cells or 8 cells or 10 cells or whatever it is. The scale at which you set it is going to change the value that gets calculated, because the slope really does change at larger scales than it does at finer scales. So let's just, by default I've got HASA 30 meter SRTM selected over here, so it filled it in. Before I say output map, let's go to the optional tab over here. And let me just resize this so you can see everything going on in here. So over here, the most important thing is this morphometric parameter in the window, size window to calculate. And we click on that, we have all the stuff including slope, aspect, profile curvature, plan curvature, longitude, cross-section, cross-sectional curvature, and a whole bunch of other things, and then feature. So for example, if we click slope, and then we have size of processing window odd number only. So a 3-cell slope is the same slope that would get calculated in R slope aspect. Let's bump this up to like 11, right? So this is an 11-cell slope, all right? 11-cell neighborhood slope. And let's just hit, oh, whoops. I'm going to go back to required and put slope 11 cells, right? Just so I know what I'm doing here. I hit run. Okay. And then I'm just going to minimize this for now so we can look at this window. Oh, interesting. The colors are, in this case, the Viridis colors. So if we click on our slope 11 cells and we go to set color table, we go to the define tab, and where it says name of color table, we just look for the one actually that says slope. So this will set the colors the same to our other color slope map. I'll close that. And now let's go over to our other slope, and let's go back and forth. Look at that, all right? You see what's happening? Let me zoom in on some of these areas here, right? So this is our 3-cell slope we calculate with our slope aspect. And here's our slope at 11 cells, right? You see the values are actually different. They're changing between them because of this, right? We're basically, did I have this thing still set to 2200? Yeah, okay, sorry. Look at that, right? We're basically seeing less detail, right? Less detail. We're blurring it. So we're looking at a larger, more macro scale of slope. Now that's really interesting. I'll go back to my previous zoom. So whatever we set in terms of our neighborhood size over here, right, that is going to set the scale of the analysis that we want to do. Now this interacts with the resolution. So I have a 30 by 30 meter resolution with my SRTM. So really 11 times 30 is 330 meters. That's the actual measured scale, the distance scale over which I am now calculating slope. So let that sink in for a little bit. This number times the raster resolution equals the number of meters on the ground, true resolution that I'm choosing to conduct this analysis in here. All right? Okay. Now, we could do slope, we could do aspect, but one of the really cool things it does is feature. And what this is, it classifies features like valleys and ridges and peaks and all of that kind of stuff. Now you can tune some of this stuff with these things here. Again, read the manual page to learn all about that kind of stuff. Here's an example of what it will do. Go back to the required tab, and let's just put L forms, right? Landforms. And we hit run. And then I'm going to push that to the back. And you're going to be going, what is this? Or what is all of this? So let me change this legend over here to be our landforms. All right. And now you see, whoa, it's huge. Why I don't want this big. So now I'm going to show you some of these little secrets in here. What we'll do is we'll go to the Advanced tab, I believe. And, oh, they change all of these things from time to time. Let's just see. Size and placement. I'm going to do a little thing where I'm going to do, let's see, 1, 5, and 10 to 30. So this is, read the little tagline here, basically, to tell you what I'm doing here. I'm basically shrinking the thing, putting it down here at the bottom like this. Well, okay, what did I do? This is new. I didn't used to rotate it like that, which is kind of funny. Let's just try this and see what it does. Oops. Alright. I clearly have to read the manual for Grass 7.4 because it really didn't used to rotate it. So we'll just leave it large for now, and I'll figure out how to do that for next time. You see, even the professor, things change all the time. So don't feel bad yourself when you're like, what is this? What did I do? What am I doing over here? Everybody has to remember this stuff, okay? So that's a little life lesson. Don't be afraid to fail, because failing is how you learn new things. Anyway, sorry about that. But basically you can see it's showing us our, our key over here. So let's go back over here. Let's again only show this. So the key here, when we're going to 3D, whatever layers are visible, it's over here with the checkbox. It's going to try to render in 3D. It's going to read the number inside the cell and it's going to assume that that's elevation. So if the number is a category, it's not going to be meaningful in 3D. So instead what we want to do is to read the numbers from this map and then choose to put the colors on our cell. So let's go back to the 3D view. Over here, you can see it basically takes us right back to what we were looking at. We will go to our Data tab, we'll go to our Color, and we will select our landforms. And now we can start to see what's going on, all right? So we can, sorry, I meant to get the pan tool. We can do this. We can go over here, and we can use our telephoto lens to zoom around in here, all right? And we can actually see the channel, right? See the channel coming down here? And see the yellow ridge right over here. And over here, we can see some of the red peaks and the green passes, or the saddles that I talked about in classes. And we don't really have too many pits, but there could be a few pits in here, right? And if we turn our perspective from this side, we can see some of these things. And again, we can go back to our appearance, and we can, well, let's brighten it up a little bit. Up our ambiance, our ambient light over here, just a little bit. And our view, let's just zoom ourselves in real quick, right? So you can see how this can be addictive. Now you can actually see some of these peaks pretty well. Now again, this is scalar. We did this over an 11 by 11 neighborhood. If we did this over a 3 by 3 neighborhood, we would definitely have a different, more detailed, but potentially messier, not as easy to understand output. So I encourage you to mess around with that when you're doing our param scale, to do different scales for your different analyses and see the difference between them. So I think that will do us for about now. I'm going to end with one final tip, all right? And that's closing grass. I didn't show you how to do that last time. The proper way to do it is to go to File, either close the GUI first if you want to do that, or really go to Quit Grass GIS right here. It'll say, do you want to close the GUI or do you want to quit? And you hit Quit. Then it'll say, do you want to store the current settings to a workspace file? If you select yes, this is just like saving a QGIS project file, meaning it saves the layers and their order, the color or styles that you've applied, but it saves no data. Grass takes care of saving all the data. This is just the styles and the layers. So if you want to get right back to what you're looking at here next time, or if you want to move to another computer and get right back here, save a workspace file, and when you start up Grass next time, you will load it in from this menu up here. So if I, oh whoops, I hit cancel so I didn't save it, but let me just, I'll do a real quick start of grass again, just to show you how I could have done that. Okay, just start grass over here. I could go to File, Workspace, and then Open, and I could find my workspace file, and I would be right back where I was. All right. Personally, I almost never do that because when I do grass, it's all about analysis. It's not about necessarily the layers that I'm looking at or the styles. There is a print composer in grass. You'll see it under the File menu over here called Cartographic Composer. But it's not as powerful as the one in QGIS yet anyway. So I don't see there to be any real requirement to save my workspace most of the time, unless I'm, again, working over multiple computers or something like that, which I tend not to do. All right, that'll do it for now. I will see you on Thursday.